Okay, hello everybody.
Oh yeah.
They gave me the hi sign so I can start talking now. So thanks to everybody for being here. We're going to start with a safety minute. So Michael.
Okay, good. Good afternoon. For those of you who don't know me, I'm Michael Brandt. I'm the Deputy Lab Director for Operations. And there's two things that actually three items that I'd like to discuss. First of all, we have two volunteers. Raise your hand. Okay, it's back here. If we have an emergency, just follow them either out the back doors here, or Mike and I did check this door. If you go out this door, the door, that's the Secretary Perry's door now. And just follow the steps and we'll meet everyone out in the parking lot. And the second point that I'd like to discuss is personal protective equipment use at the laboratory. If you use personal protective equipment, gloves, face shield, glasses, some sort of an apron or whatever to do your work, please inspect it. We had an injury recently where where we had holes in a glove and someone received a liquid nitrogen burn. Then we looked across the laboratory and we discovered that we had other gloves that had holes in it. We don't have to conserve gloves. We have plenty of money to support safe operations of our work here at the lab. So inspect your personal protective equipment. Last point is, Wim and I were talking as we were coming into the auditorium, and we have students who are here riding bikes. And when you ride a bike downhill, don't jam onto the front brake, and certainly just don't use one brake, you pump your brakes. And that's much more effective in slowing a person down. We had a student who was alarmed by turkeys crossing the road, and they didn't pump the brakes and spent too much time on one brake and fell. So we don't want you to fall. So that's just another point. So with that, I will turn this back over to Mike.
Great, thank you, Mike. So thanks for coming today. For a little over 2 years now, I've had the privilege of leading this great laboratory, which is, I always say, is unique in its ability to carry out world-leading research over such a wide range of science and technology. What I will tell you today is that with the fiscal year 18 appropriations for the year that we're in, the nation is making a big investment in science generally, and in this laboratory in particular, and its future, and entrusting us to make the most impact with that investment. So we are doing everything possible to deliver breakthrough science in return, and that's really what I'll be talking about today. This is the third time I've had the chance to talk with you about the state of our lab. Most of these slides I used at the annual laboratory plan presentation I made in Department of Energy on June 5th, and then there are some other things that I only can give a fraction of those because you don't want to spend an hour and a half doing this. But so this is the edited version of that. But then I also have some other things I'd like to talk to you about. So I do start in talking about the lab's research. I find it helpful to start with the national need for our laboratory and others like it. And I talk about the fact that first of all, we have scientific solutions addressing national priorities: energy and energy security, resilience, economy, the environment. Highest award being the National Medals of Science and Technology, such as Paul Elvisatos won here for his work. And discovery science, that is, Nobel Prize-worthy discoveries are at the top of that line. And we have also 13 of those at the laboratory, most recently for a salt pearl emitter. So that's what we provide to the country. In addition, unique scientific capabilities and facilities, like our national user facilities and advanced instrumentation. This is our direct electron detector for electron microscopy. We have managed large research teams that we have to be very good at, and we are, not only at the user facilities, but also at organizations like the Joint Bioenergy Institute. Important technologies with long, risky R&D paths, which we have to engage industry with. And finally, a diverse group of highly trained, creative and committed scientists and engineers. And that's an important part of what we do here, and I'll talk some more about that. We are an extremely diverse laboratory, even among national laboratories, with many projects that integrate several scientific approaches. We received $948 million of funding support last year. That was our record year. Our federally funded research enterprise, which is about 850 million, so 948 million is what we had, about 88% of that is federal. To put that in perspective, if that was listed as a research university, there's only one research university that has more federally funded research than ours in the country. We would be second. Okay, more than all those universities you hear about, we have more federally funded research than they do. So this is a large laboratory, it's a productive laboratory. So the Office of Science supports about 66% of, about 2/3 of our research. I will say only once what these acronyms are: the Advanced Scientific Computing Research Program, the Biological Environmental Research Program, and Basic Energy Sciences, afterwards known as OSCAR, BER, and BS, are each about $150 million each. High energy physics and nuclear physics together are almost as large. So that's our Office of Science part. Then the other parts of Department of Energy, the energy programs, especially EERE, Energy Efficiency, Renewable Energy, and other programs, including NSA, altogether, it's about 89% is actually the total of all the Department of Energy here. So we are a DOE-owned laboratory. That's most of what we do. On the other hand, we have quite a bit of other work, including other federal agencies, NIH, Department of Defense, and Homeland Security, and an important part in non-federal sponsors, still $50 million, still a pretty large research enterprise with private industry Californian foundations. And we are an extremely diverse laboratory with many projects, as we said, and we do this research in support of the DOE's mission. We carry it out in 3 approaches, and I talk about this quite a bit. We have the big user facilities, which way we reach out into the larger community, large team science projects with partner labs and universities, and core research programs. And all of these feed on each other. That is, many of these researchers use those user facilities, for example. And this is one I didn't have in my slide there, but this is just a thing that we keep internally about some of our major programs. And these include our user facilities and some of the major construction projects. It's not everything in the laboratory, but things that are getting special attention. And you can see general picture is this is FY17 funding that we had, FY18 funding. In all cases, and you can see your favorite here, there's user facilities, NERSC, YesNet, and so forth. In all cases, the 18 funding is as good as 17 funding. But in some cases, in bold, are quite a bit better this year. So we had the Integrative Genomics building, which is going on up front, is actually 38 million is enough to finish that building in this year's funding. Our 2 user facilities in computing, NERSC and YesNet, which I'll talk about, had enough, 94 million and 79 million for the early parts of their big new projects, which I'll talk about. This is the environmental management work that does the cleanup of our Old Town and soon to be Bayview sites to do new facilities. That had been 9 million last year. It's 41 million this year. The ALS upgrade project, which had been funded at a level about 5 million, was 30 million this year. And the Agile Biofoundry, a new program starting up, got to what we hope will be its steady funding level, 20 million. So this is what I mean by a good investment this year. I'm expecting our total funding to the lab this fiscal year will exceed 1 billion for the first time. The House and Senate appropriations bills for FY19 will look, if enacted, would be that good or better. So on behalf of the taxpayers, the House and Senate have made a large investment in the science we do here. So you should also feel very good about that. You should also feel that we all have a very deep and great responsibility to make good on all that investment. So when I'm talking about the programs, I will not show all the slides that I gave in that. So I'll be doing a little bit of picking and choosing. So if you don't see yours, next year we'll have it. But I do always include our large user facilities. With great support from the sponsoring programs, we are actually able to do what's needed, which is to upgrade and provide new instrumentation for these facilities every so many years. So the Advanced Light Source is getting this major upgrade to keep it at the forefront of its X-ray science for another 25 years. Molecular Foundry is actually just submitted 3 proposals to a major funding opportunity in quantum information science. That's an initiative that I'll talk about. NERSC, I'll talk about its major new upgrade, NERSC 9, which is we're in the preliminary design stage for. And ESNet, its transformative upgrade is actually in the conceptual design view, so they have both big projects coming. And of course, Joint Genome Institute, that big building across the street there, is going to be its home. It's getting a brand new facility, a very big investment from the Science Laboratories Infrastructure Program. So there's a lot of renewal of these user facilities across the board. We also, our greatest strength is the large number of world-leading researchers. I just use this to make a few points. The National Academies, we have 39 active members of the National Academy of Science and 14 of the National Academy of Engineering, 14 in the last 4 years. We have similarly large contingents in the other societies like the American Academy of Arts and Sciences and the American Association for the Advancement of Science. But that's actually a backward-looking figure of merit. Looking forward, we want to develop new members for these, and we particularly give a lot of attention to our early career researchers. And the new news here is they just announced the Early Career Research Program Award winners for the Office of Science. We had 6 of those. That's the most any lab has ever had in 1 year. It beats our record of 5 from last year. And there were 30 in the whole laboratory system. There were 30, and we had 6. So congratulations to Ethan Crumlin, Karen Davies, Colin Office from BES Awards, Dan Dwyer and Toki Suzuki from High Energy Physics, and Colby Giorgini from BER. Great job, people. We developed a set of overarching strategic priorities for the laboratory. We come together to do that once a year. We renew this picture. For this year, it is to go around the biological environmental science at the biocampus. You can see the, of course, JGI, one of our user facilities, JBay, KBase, and I'll talk a lot about BioEPIC and what that means for the laboratory. Science with the upgraded Advanced Light Source. Again, the big ALS upgrade I was talking about, but also the Molecular Foundry renewing and all of the materials and chemistry research environment around that. Breakthrough science at the exascale. Our user facilities, NERSC and ESNet, but all of the computational and mathematics research that connects with all the lab science, epitomized by the camera project, but of course there are many others. And the 4th priority area is discovery science and fundamental physics. We have several projects going on in high energy and nuclear physics and novel accelerators. And our 5th priority is infrastructure renewal, which is not usually discussed in that way because it is so central to everything we are doing that we have altogether have elevated that as a overarching priority for the laboratory. And then within those overarching priorities, we have our individual initiatives, what we're doing to advance certain areas of the laboratory. We give great attention to using LDRD, Laboratory Directed R&D. That's our discretionary funds. So we have 3% a year. To explore a frontier of DOE science, Horst Simon is the Chief Research Officer, organizes and manages that program for strategic benefit. Just to know, in the past, the Molecular Foundry and JBay and BioEPIC and these Cosmic Frontier experiments all started out with LDRD. That's how they always get their start. This year, we have LDRD lab-wide initiatives in advanced biogenic chemicals and materials, water energy resilience, machine learning for science, early career LDRD track, which I'll talk about, and next generation microelectronics and computing. In the early career LDRD track, that's part of our conscious campaign to develop our outstanding early career scientists. As I already mentioned, in 2 years, 17 of those have been awarded. That's putting our own institutional funds into our early career award winners. It turns out of those 17, 10 of them were women so far, which is remarkable. We have developed an extensive mentoring and development program for this group as well. Then we have additional lab-wide initiatives on quantum information systems, electron microscopy, microbes to biomes, and applications of small accelerators. I'll talk about some of these that we're promoting in ways other than our LDRD. So these slides, I'm not, when I do the annual lab plan, I talk through all these. I'm not going to take that time, but it shows you what it is, some of the things we're stressing this year. Quantum information science is the study of how to take advantage of quantum mechanical effects to develop new types of computers, sensors, and controls. The DOE Office of Science announced a major initiative in QIS, and it's going to be part of a national quantum initiative that will be announced in the near future. Because of capabilities across this laboratory, we were in a position to get a fast start on this. So we have a lab-wide working group looking at how we can advance this. We have proposals into, already successful proposals to the Oscar program, have proposals into BES and to HEP. Irfan Siddiqui and Jonathan Carter are leading this lab-wide effort. This is something where we're developing quantum computation and sensors and materials and fabrication and controls. This is a very important, and a lot of you will be seeing parts of this around the laboratory. Another lab-wide initiative is scalable and interpretable machine learning for science. I'll just give you one example of that. These neural networks that are taking images, tomographic images that actually can learn to automatically scan and recognize features in these very quickly. That's something, instead of doing face recognition or things that Amazon or Google are doing, we're trying to solve science problems with the same sort of deep learning. And we also have a wide range of LDRD projects and machine learning really across the whole laboratory at this point. And that's something also we see in our position as a position to be a leader in. Another lab-wide initiative, the Water Energy Resilience Initiative. We have lots of individual projects on this, but it's all around the problem of water energy resilience research. And it has to do with basically the problems of how to make better use of our water is as scarce a resource as energy is, and it deals with the environment in much the same way. And everything we do with water uses energy, and everything we do in energy uses water. So it's part of a coupled system for the Department of Energy. We have been involved with BES and BER for these programs, but there's a big hub initiative that the Advanced Manufacturing Office at DOE is putting out in July. And we've been gearing up to get ready to, with a lot of laboratory, industry, university partners to jump on this. We hope to do. The Advanced Light Source Upgrade is the biggest project that we are doing here since the Advanced Light Source was built 25 years ago. Science with that upgraded Advanced Light Source is central to our priority for basic energy sciences. It represents a big investment from the BES program in us. We will have the world's highest coherent X-ray flux, and already we're doing some things. This is actually some new structures are taken in soft X-rays using the cosmic beamline, which is a beamline is sort of built as a leading edge of looking ahead to the upgraded ALS. I'm directly supervising the ALS upgrade project, working with Dave Robin, the project director, and working closely with Steve Caban, our new director of ALS. Weekly, as we make progress on this, we have $30 million this year. As I said, the House and Senate bills both have $52 million for next year. So that's still increasing. The current cost estimate is $368 million. We're having our big CD1 review is actually coming up. And so you ask, what the heck is a CD1 review? And so there's a thing that shows you that, because it comes up in so many of our projects. The way projects go in our system is it starts with basically we're told to develop mission need for a new project. CD0 is the time you approve mission need. That means the department says this is something we want to do. We got that in September 2016 for the advanced light source upgrade. Then there's you develop the conceptual design and then get that reviewed at the CD1 stage, which approves a cost range. So we're hurtling towards a CD1 review in July 19 and 20th. We're getting ready for that day and night. And then that moves us into an execution phase, which starts out with a preliminary design, a more detailed design, get that approved at CD2. At CD2, that is the baseline. That means we have to build this project for this cost and the schedule, and then we go ahead and build it. At CD4, we're done. So this is, we are, as you'll hear, we're awash in CD1 and CD2 reviews. So that's how I will spend the rest of my summer, is doing CD1 and CD2. And they're usually associated with CD3A. 3A means you're getting advanced approval to make some long-term requisitions, actually get some things you have to get out and get started acquiring. So this is an exciting time for this project and for several of our projects. Also, Jeff Neaton and his division directors in ESA developed a strategic vision for ESA, but a lot of it has to do with making best use of its facilities, and in particular, with the Old Town redevelopment opportunities. They're cleaning up Old Town. That's in the area around the advanced light source and surrounding buildings. And this is a great opportunity for us. Removing the buildings and surrounding material will create an opportunity to design and build an integrated research campus in that area with the ALS as the base, but to do lots of other things. So we're extremely grateful, not only for the ALS upgrade, but for this support from the environmental management program to get on with this. And so you'll see a lot of work going on in this area over the next year. Another development of our site is the BioEPIC program and building, Biological and Environmental Program Integration Center. There's going to be a full overview of this on table tomorrow, so it has more than I can say. But in addition to those budget milestones, a big milestone in our laboratory was getting the CD0 mission need approval for BioEPIC. This came up on March 8th. They gave us the chance to come forward to them with a with a review, and we nailed it. And we came in and we did a very good job of putting this program forward. It got CD0 approval in record time. The initial cost range is up to 140 million, which is a record cost for such an SLI program. Thanks very much to the Science Laboratories Infrastructure Program and to BER, which is the program that sort of is the principal sponsor. So quantifying and predicting micro-plant interactions in terrestrial systems is critical to much of the BER mission space. And this is the facility we need to press forward with that. And that, so you understand, that would be the next building going up next to the IGB building down across the street. I'm just picking out for the various areas one of many slides in these discussions. So ALS. So in this particular, our Mary Maxson and the division directors in bioscience area have developed a strong strategic plan that involves these themes of energy, environment, biomanufacturing, and health, and all supported by technologies. We are the largest DOE laboratory in the space, and something we're quite proud of, including the Joint Genome Institute and the Joint Bioenergy Institute. And as one of our major user facilities, the Joint Genome Institute is of particular importance to us. So we're very excited about the fact that the IGB building, you see it's concrete construction up to here, and now it's putting in the upper buildings where they're putting in the steel construction now is going on. That's getting ready for occupancy by next year. It will give a closer connection with the rest of the lab and the computing facilities of the laboratory. Nigel Mounsey, the JGI director, is organizing a campaign to import the public data sets from JGI into KBase, which is the data user facility. This is a big opportunity for us, and we will hope to do great things with it. For our Earth and Environmental Sciences, Susan Hubbard and the division directors developed that strategic vision last year, and it actually is balanced. It's both BES and BER, as well as several other energy technology areas fund that. So they do a lot of work with the rest of the laboratories. So we already talked about, they are part of the BioEPIC program and building that we've already talked about. And they're also a co-sponsor with Energy Technologies area of the Water Energy Resilience Initiative. So you're showing two of the great cross-laboratory cutting programs that EESA works with. There's also researchers from this area are developing with UC Berkeley an accelerator for scalable solutions for grand environmental challenges like urban precision agriculture. These projects will be supported by foundations and will include partners to implement those. That's a new thing that's sort of extending the laboratory's basic research out into implementation. So that's something that's also going on. Kathy Yellick and the computing sciences leadership develops a strategy for the computing sciences area. Again, I'll pick just a couple of slides to capture that, but we are experiencing exponential growth in scientific opportunities enabled by all of these user facilities and other major facilities, and the opportunity offered by large-scale data analysis and simulations. I'm a high-energy physicist. The Large Hadron Collider, we produce more data than anybody does, and so that's leading the way on this. But all the other fields are coming along and producing also massive data sets that need this sort of powerful networking and computing to operate. And Berkeley is ideally suited to serve as a test bed for developing this sort of super facility model for science. For example, the fact that at the new LCLS2 free electron X-ray free electron laser at SLAC, they will be able to analyze in real time for certain experiments that need it, their data through ESNet to NERSC, so they can actually make adjustments in it as they go. NERSC, it's our big, well, actually the fastest 500 computers in the world, that report came out today. For those of you who follow those things, Horst Simon was part of the group that got that out of Frankfurt today. Turns out NERSC Corey is 10th on the list, and the new Oak Ridge facility is first. So DOE has 6 out of the top 10, I think, this time. Until a few months from now, when China will jump back ahead, but it's okay. We're in the race. Sudeep Dosanjh leads that effort, and it involves both this facility, Corey, but also an outstanding staff, because we bring more scientists, 7,000, and more research projects into high-performance computing than any of these facilities do. That's our role. So the new upgrade is NERSC 9. On August 7th to 9th, we'll host a CD23B review. So it's the baseline where we know the project will be done here. And that's about a $130 million scale project for ready for FY20. So we're very excited about that. Another big investment. You also know ESNet is the high performance network that services the whole system for the DOE. And it is going through a new upgrade, ESNet 6, which is really a software defined network. It's a new model for ESNet, so it's going to be a very large project and very disruptive. We hope not to the network, but to our way of thinking about science. So, so Inder Manga and his team is getting ready for the CD1 review of this project, which is coming up on June 26th. Told you, my whole summer is going to be these reviews. And this is another 130 million roughly scale project to be ready for FY21. Moving to physical sciences area, James Simons and the division directors from physical sciences developed a new strategic plan, which is out, and they'll be happy to, give you one. But it develops their plan for their 4 areas: particle physics and cosmology, funded by High-Energy Physics. There we have the DAISY Dark Energy Project for the Mail Telescope and the LZ Dark Matter Experiment for underground South Dakota. Those are $75 and $56 million. They're actually starting installation in both cases. Nuclear science, that's the Greta project, which is funded by nuclear physics. It'll go through a CD23A review for Greta in July 10th. And that's a $52 million project. It'll go to their facility in Michigan State. I'm going to talk some more about Accelerator Technology in a moment. And then the engineering division, which provides a wide range of advanced engineering services for basically all the experimental research areas at the lab. So I'll pick out just one thing here on Wim's area of Accelerator Technology. We're just getting word. We, of course, have these laser plasma accelerators that now get 5 GeV electron acceleration in a very small beam. Got the second beam line, which will allow, among other things, scaling 2 of those, so you can actually get up to 10 GeV. This is something that we've been ready to go. We've been pushing. We just got approval from both High Energy Physics to be the principal sponsor of that, but also for the first time, Fusion Energy Sciences program is actually coming in and being a partner on this because we're going to do high energy density science with it. So this is a big upgrade for us. We're really looking forward to it. It's a real breakthrough for this program. We also have in many areas, and this I'll choose one, we're accelerating transition to industry. So in this case, into biomanufacturing is something that this laboratory has a national reputation for. We have associated with JBay, we have the Advanced Biofuels and Bioproducts, which has been going on for some time, is very active, funded by the Bioenergy Technology Office at DOE. But new is the Agile Biofoundry, which is to accelerate the design, test, build, learn cycle for biomanufacturing. And this is a new $20 million per year program that's really getting going at this time. And we're very excited about it. So the main picture you should have is we're getting a lot of projects here. We've got a lot to do. We need to, get out from here and start building all these. But we have to show that we can actually operate these very, very well. So our commitment to operations excellence around the laboratory is key. We get these projects because of our reputation for research and our ability to perform in operations and construction. And we need both of those to keep building new projects for our future. Actually at the lab plan, Michael Brandt gave a really great presentation for our infrastructure plan for the laboratory. It went over very well, worrying both about everything from fixing all the decaying infrastructure that's here to building new facilities for the future. In other areas of operations, we continue to build and share best practices for cybersecurity. This is getting steadily more attention for reasons that you read about in the news and something we have to be very good at. Our new facilities, IGB. I'm gonna show a whole slide on our DEI initiative, so I'll save that. For safety, we're doing a safe training program completed for over 300 operations supervisors. That's a multi-laboratory effort that we bring in here to do. And this comes from the infrastructure proposal, which shows all the level of our deferred maintenance and new construction. The big story is we're investing twice as much on infrastructure repair and renewal as we did a few years ago. And we're just turning the corner where we're starting to bring the backlog of deferred maintenance is just beginning to come down now. We'll have to stay at this for another decade or so. Of course, and we're working closely with environmental management to complete the Old Town demo and adjacent to soil remediation. That's very important. And starting to prepare do the work for the Bevatron site and preparing for the BioEPIC. So the picture is world-class research requires modern laboratories, which in a laboratory as large as this or any research university means constant development of new facilities. It's not that, gee, it seems we're doing a lot. If you don't keep doing this, you fall out of the forefront for what we do. So as you know, for people who've been around at the time, we've had a series of buildings that already exist here as we work our way through those. We're right here getting the integrative genomics building done. Old Town demolition and Bayview site cleanup are crucial to this. We got our CD0 for BioEPIC, so that's going to go forward. And we're thinking for the future about both, for example, a chemical observatory and the Old Town site and new buildings for the Bayview site. This is a constant program of, lab facility after facility about what we need to keep our research. And so the Office of Science is very important to this. Environmental Management Program is very important to this. And the University of California has also supported this effort in important ways. We have to scale up our support for project management. We have, at Fermi Lab, I was at a laboratory that was project dominated. We had more projects being reviewed than any laboratory. This has not been a project dominated laboratory, but we are going to be in the next few years. And so we need to scale up and improve our processes, resources, structures for project management to deal with this. We've brought in an experienced consultant to think about this and help us. We're building up our project management office. Ken Robinson's going to be in a dual leadership role for the moment, both in the project construction office and project management. But John Corlett, we're bringing in from the LCLS2 project back to be the deputy project management office leader. And we're going to be adding new people here. We're actually also looking for a campus infrastructure planner dedicated to working with the leadership on developing our sites for the future. So this is something we're putting more and more emphasis on. And just you got a good one-pager on this from Michael at the beginning, so let me add my voice to it. I think whenever I talk to the laboratory, I emphasize the right safety culture. Each of us needs to take personal responsibility for our own safety and the safety of the people around us. We have made great improvements in improving electrical safety, lab safety, attention to slips, trips, and falls, but we need to improve in other areas. You need to make sure that the PPE is in good shape, as you just heard. We are, with all this construction going on, we're paying a lot of attention to construction safety, including for our subcontractors. Well, you already got the ad on this is a dangerous place to ride bicycles if you're not very, very careful. This is something I would like you to renew your attention to. We need to keep everybody who works here safe. I also, as you know, always take an opportunity to talk about the diversity, equity, and inclusion of the laboratory. We had our Director's Distinguished Women in Science Speakers series. Jennifer Doudna gave the first one of these. We just had Jerry Richmond for the second one. Worked very well. But we also have this DEI program that's developed with a senior leadership group and a broad set of people from all of the laboratory that have been part of this. I'd like to call out, we had our ERGs, our employee resource groups, out at the cafeteria today showing their wares. The African American All Access Veterans, Lambda, Women Science and Engineering, and a new one on for actually Hispanic and Native Chicanos and Native Americans. I encourage all of you who have interest in any of these areas to join Employee Resource Group. It's an important part of making this the laboratory that we should be. So I'm going to end up talking about principles of stewardship. The nation has entrusted us with a unique natural resource here. And 6 months ago, I started discussing a laboratory stewardship initiative, which we are now launching. It's not because anything that the Department of Energy or anybody else is imposing on us, but it's our commitment to the long-term mission of the laboratory. All of us are responsible for handing off a laboratory in 10 or 20 years that's in better shape than the one that we received. So we all must be part of the stewardship of this laboratory. And there are three parts of this. There's the research, the people, and the resources. So number one, high standards of research. As a world-class research laboratory, we conduct research of the highest quality with honesty, accuracy, efficiency, and objectivity. That's why we're here. That's what we have to uphold. We communicate our research to the public and to the scientific community. We commit to follow a strategic plan, and we publish and share our data and transfer technology. So for this initiative, we developed these principles to guide it. And there's the new website, which has all these principles listed. And then from these, it has a link to the practices by which we do these things. So I've just gone through a round of developing this page of principles. I've talked to all the division directors of the laboratory to make sure that we are together on this, that they've signed a page saying we commit to this. They will be talking to everybody else in the laboratory in the ways that their divisions do about these. So this is what it means for science. It has to do with, as it says, the scientific enterprise is built on a foundation of trust. Effective leadership of people. We thoughtfully manage and lead our staff because they're central to achieving our mission. We strive to ensure a safe working environment that we've been talking a lot about here. We foster a culture of respect and collaboration for everyone in our community and advance the principles of diversity, equity, and inclusion. And our people are our most valuable research. This is how we ensure our staff are able to be at their most effective by doing this. And I hope and I believe that everybody here is with me on this. And then finally, our responsible stewardship of resources. The nation has entrusted us with world-class resources. We need to protect and maintain these resources. Physical and digital infrastructure includes this infrastructure initiative we have going on is, of course, an important part of that. We need to secure our site's equipment, keep our people safe. We had a crazy incident here a year ago, for those of you who remember, which gave us an example of why we need to do this. Financial accountability, we exercise the highest standards of financial accountability and transparency. We also need to, for example, make sure that all our principal investigators know what their responsibilities are and follow them. And so that's something that we're going to be talking a lot about. And we manage all projects to the highest standards of performance. And that, of course, you already heard a lot from me about. So you can see these are the things at the highest level we need to pay attention to. We have to understand that the nation's made a big investment on this. We need to not only produce great research, but take care of the laboratory. So the leadership team will individually and collectively be held accountable for successfully performing our mission, identifying risks and avoiding them. So these are in that stewardship principles. I would ask you to just accept and understand the fact that each one of you is a steward of this lab. You're committed to the mission, and so this is how you do it. We are going to be communicating the stewardship values and expectations. This site will be where to start. I encourage you all to look there. We'll be developing a leadership curriculum to make sure that we're training our division directors and other leaders in what we mean and how you do that, and hold ourselves accountable for the lab success. Sorry. That's it. Thank you. Okay, I'd like to take questions. You have some? And there are, let's see, we have one microphone here and one over here. So, and we are streaming this to the laboratory because we have this, for a lab this big, as we were talking about earlier, we have a very small auditorium, so we reach out by streaming. So please, if you have a question, wait a moment for a microphone so everybody can hear you. So who would like to start? There's this moment of shyness before. This is not used to, but it always happens at this point. Okay, no questions? Anybody out there in cyberspace? Yeah. Gee.
Hi, I've read an article in today's The Hill about that the problem with people, well, the climate skeptics are more like innovation pessimists. And in the same article, it was cited that Secretary Perry earlier this month filed to have the Defense Authorization Act used to mandate DOE have operators buy energy from coal-fired plants and nuclear plants. Just wondered if you could comment on that a little bit.
Yeah, well, let me say a couple parts of that. What I'm most qualified in and most secure in is the laboratory's research as opposed to regulatory profile, which I know as much as anybody who reads the papers, just to be clear. I will say that the support across the government, from the Department of Energy to appropriations, for all the research parts we do here has actually been very strong, including, frankly, not only basic research, but actually the EERE programs actually are doing quite well here. Now, yeah, I'm not a good expert on the regulatory things. So I don't have too much more to add to that. I read with great interest. You know, the fact, let me say, the thing that has happened that's revolutionized the energy space, frankly, is cheap natural gas has done more to revolutionize energy around the world in this country than anything. And it happened so fast that I think all the other parts of the system are straining to keep up. And as you know from reading that every day, and I think that has been the thing that has completely disrupted the world energy equilibrium. So that's as much as I actually know much about. But I will say, we get very good support here. Everybody I talked to in Washington actually strongly supports the fact that we, as a basic science laboratory, we have some very important energy technologies and a wide range of energy technologies, not only energy efficiency, renewable energy, but fossil energy, nuclear energy, grid security, that actually build off our base as a science laboratory. And that's something that I get very strong support for. I've had no pushback against that as the right mission for this laboratory. And when I present the annual lab plan, that's what I present. So, okay, other question? Okay. All right. So if that's the case, let me say just a couple of closing remarks then. One is that I talked to you mostly about the strong support we get for all the work we do here. And the reason we do that is because of the extraordinary reputation this laboratory has at this point, both for its research and the way that it operates and manages that research. Okay. This is really, in the end, the way the value system goes. We're not in this, to, make more profit on what we're doing. In the end, our reward is if we do a good job, we keep getting exciting science projects. That's the value proposition. So right now, actually, this is working very well for us. And so I encourage everybody to do, to keep getting these great science projects and doing more science. We just all have to keep doing a very good job in every one of these projects we're doing. It's the key to our success there. If we do that, everything else will work for us. Okay, that's enough. Thank you.